Hello and welcome again to the second part of Ethernet switching for CCNA level. So on this part 2, it's time to look at some configuration. So I have this demo lab here where we will go over some of the concept that we discussed in part 1, and that's mainly the configuration of VLANs and how VLANs are used to isolate broadcast domains and different departments and so forth. And on the second part, we will look at configuring a trunk between these two switches, switch 1 and switch 2, and transport some of these VLANs, VLAN 10 and VLAN 20. So let's just quickly go over this topology to clarify things before we start configuring. So we have two switches, switch 1 and switch 2. PC1 is connected to gigabit 1.1, PC2 to 1.2, 1.3 is connecting PC3 and so forth, and it's the same convention for switch 2 where PC4 is connected to 1.1, and they are all on the same subnet 172.16.10.0/24. PC3 and PC5 are on VLAN 20 and they are on 172.16.20.0/24. I'm assigning the last octet as .1 for PC1, .2 for PC2, .3, a .4, and a .5. So let's start by running some validation before we get started. And actually one thing that you could do is to take a snapshot of this topology so you can have it on the side and refer to it as and when needed. So let's hop into our sessions. This is where I have my PCs, PC1, 2, all the way to PC5, switch 1 and switch 2. So let's hop into switch 1. The first thing I would like to check is show VLAN brief. This will show me what VLANs, which VLANs are configured on this switch. And there is the native VLAN, VLAN 1, and VLAN 1002 all the way to 1005. So there are no VLANs configured on switch 1 for this topology. Would you think that PC1 would be able to ping PC2? And can they ping PC3? We haven't done, remember, we haven't done any configuration. We haven't added any configuration on switch 1. So as per this configuration here, you can see that all these ports are on VLAN 1. The default VLAN. So all these ports connected here are all on VLAN 1, which means that this switch is actually a single broadcast domain for all of these hosts and this switch also. Now we are not looking at what happens here in terms of are we trunking the VLANs, are we not? So we will focus only on PC1, PC2 and PC3 for the time being. So in theory, PC1 should be able to ping PC2 because A, they are on the same VLAN, and that's VLAN 1, and also they are on the same subnet. So routing wise or LAN wise, they are on the same subnet. However, PC3 is also on the same VLAN for the time being. Forget about what we have here in this drawing. So PC3, based on the configuration of the switch 1, is also on VLAN 1, but it has a different IP address. It's on a different subnet. So in theory, PC3 should not be able to ping PC1 or PC2. But let's validate this. So starting with PC1, let's try to ping PC2. One more thing before we start actually is this command here. This will be very important to check, to consolidate what we have learned about how the switch builds its own MAC address table. So if you look at the MAC address table, I have a MAC address for 0/0 and 0/1. So 0/0, 0/1. I have MAC addresses learned from switch 2 on this interfaces, but nothing has been learned yet on gigabit 1.1, 1.2 or 1.3. But once we start running some ping tests, what happens is frames will be received by switch 1 and the switch 1 MAC address table will start getting populated. Let's check this. So going to PC1, I'll ping PC2 and I get a response. Here you can see that we have learned the MAC addresses on 1/1, 1/2. So that's PC1 and PC2. Now let's try to send the frame or packet from PC3. So let's just ping PC2, for example. So there's no response. PC2 is not reachable. But the MAC address table should be populated, which is the case here. So as you can see, VLAN 1, for VLAN 1, we have port gigabit 11, 12, 13, and we have all the MAC addresses that we need. So we have done some basic validation just to confirm what we have covered theory-wise on part 1. Now, let's start configuring our two hosts to be on the same VLAN, and that's VLAN 10. So going to switch 1, you go to your config mode, and you have to first create the VLAN, so VLAN 10. And as best practice, I will name it. So let's name this one HR department. So now the VLAN is created. If you do show VLAN brief, you can see that VLAN 10 has been created and the name of it, it's active, but is not actually assigned to any ports. So let's assign VLAN 10, or let's make gigabit 11 and 12 part of VLAN 10. So let's start by adding these two interfaces or ports to VLAN 10. There's two ways we can do this. We can take a single interface at the time, or if we want to make things a little bit faster, we will take a range. So we go to our config mode, and I'll prefer in this case to use a range configuration to make things a little bit faster. So the syntax is gigabit 11 and then -2, which means I will be applying this configuration to both interface gigabit 11 and 12, and this range obviously can go all the way to 5 or whatever depending on your configuration needs. So I'll start with gigabit 11 to 12, switch port mode access. So here I'm setting the port as access, switch port access VLAN 10. Show VLAN brief. Now we have our ports in access mode for the HR department and on VLAN 10, and you can see they have been removed from the first lines here where we had VLAN 1 enabled. So these two ports now are sitting on VLAN 10. I'll do the same thing for PC3 gigabit 13, where I will assign it to VLAN 20. So here I will use just a single interface, obviously. Switch port mode access. I have not created the VLAN, but let's see what happens. So here we get this notification, access VLAN does not exist, creating VLAN 20. Now, as best practice, let's just check the configuration before and after. So let's get rid of these messages, or at least prevent them from coming up and annoying us. Right. So we do show VLAN brief once more. And I can see my VLAN 20, but it's not named. So that's the default naming, and it's assigned to gigabit 13. I would like to give it a name. So you can still go back and name it. And I will name it sales. So now I've got my VLAN set up as it should be on this switch 1. Now let's take a look at switch 2. Show VLAN brief. So no VLANs are configured yet. So let's start configuring our VLANs the same way we did on the previous switch. So VLAN 10, name HR. VLAN 20, name, sales. I'll just check my ports. So VLAN 10, that's gigabit 11, and 12 is for VLAN 20. Switch port mode access, switch port access VLAN 10. And I go to gigabit 12. Switch port mode access and VLAN 20. Save my config and save my config. So now we have to figure out whether PCs connected to switch 1 are able to reach the PCs or the host connected to switch 2. We need to have some sort of trunking going on here. If you remember on the part 1, we spoke about how a trunk actually transports the different VLANs by using the Ethernet, by using the .1q encapsulation tag. So let's see if we have a trunk established. So looking at gigabit 01, using this command, which is the normal show interface gigabit 01, we add switch port to look at all the information that are related to the layer 2. So here we can see the admin mode is dynamic auto, operational mode static access, admin trunk encapsulation negotiate, and it will be the same on the other end. So what I would like to do is to set or hardcode my encapsulation and my trunking. Switch port trunk encapsulation using .1q, switch port mode trunk. So setting the switch port or the interface as a trunk. Let's check our configuration or our interface status once more. So you can see that we have the encapsulation has changed from negotiate to .1q. And the operational mode is trunk. Let's take a look at the other side. So you see here we have negotiated and taken on the encapsulation as .1q also. And the operational mode is trunk. So the interface, this interface has negotiated its state from static access to trunk. And they're both using obviously .1q encapsulation. So going back to our topology, if we have configured these two switches correctly, as well as the trunking correctly, PC4 should be able to ping both PC1 and PC2. So let's check that. Going to PC4. Let's take a look at the MAC address table once more. There are no MAC addresses learned from gigabit 1 or gigabit 12. So let's take a look at our MAC address table on switch 2. And we can see that we got VLAN 10 and 20 learned via gigabit 01. So via this interface here, we're learning MAC addresses already. So let's start pinging from PC4. So we would ping PC1. And we have a response. And then we'd also try from PC5 to PC3, because these two PCs, PC3 and 5, are on the same VLAN, so they should be able to ping each other. Let's take a look. .3, and we get a response. So on switch 2, the MAC address table should get populated with a lot more MAC addresses, as we can see here. So the switch has been clocking up the MAC addresses of the frames coming in and the responses and so forth, and he has populated his MAC address table. Now, one thing that I would like to talk about is VTP and VTP domains. So VTP stands for VLAN Trunking Protocol, and if I do show VTP status, you can see that there's quite a bit of information here. I have set VTP domain name as CCNA. This is something that you can manually configure. And the operation mode is server mode. Let's do the same thing on switch 2. Show VTP status. VTP domain name is CCNA, and this switch is also acting as a server. So one of the things, now that we have a trunk that is established, so we have established the trunk on gigabit 01 between switch 1 and switch 2. So we have VTP messages flowing back and forth. And one of the things with VTP is to ease the management of switches. So if we configure a new VLAN, for example, VLAN 50, and we name it test VLAN. So we are configuring this VLAN on switch 1. We have not configured VLAN 50 on switch 2. But let's check what we see on the show VLAN brief. So here, as you can see, VLAN 50 has also been configured. And this is one of the things that VTP can help with in terms of management. So if you have 50 switches and so forth, and they happen to be all in the same VTP domain, then configuring one VLAN or set of VLAN on one switch will spread that configuration to the remaining switches on the same VTP domain. So this is all well and good, but there's a very bad downside to it. If you delete a VLAN on one of these switches, so for example, we will go here on switch 2 and we will remove VLAN 50. Let's check the VLAN's been removed. So VLAN 50 has been removed from switch 2. Let's take a look and see what happens on switch 1. So VLAN 50 has also been removed. And this is a very bad downside of using VTP domains and relying on VTP domains to manage your VLANs. So imagine, for example, you have a data center with 50 switches using several VLANs, and you decide to clear the configuration of one of the switches. So you want to use it, for example, as in a lab, or you want to reset the configuration, or you want to send it to a vendor or what have you. You will effectively end up wiping off all the VLANs from your data center. And that's not a good day. So how do we prevent this from happening? And this is a recommended way of configuring switches, is to use VTP mode transparent. So here I'm changing the VTP mode to transparent, and I'll do the same for switch 2. So now if I create a VLAN, a new VLAN on switch 2, say now we're creating VLAN 60. So VLAN 60 is being created on switch 2. Let's take a look at switch 1. Nothing has been propagated to switch 1. Let's create the same VLAN for argument's sake. Now let's delete it. So switch 60 is being created on switch 1 and deleted from switch 1. This should not impact switch 2 anymore, because both switches are on VTP mode transparent. So your VLAN 60 is still there and unaffected. So again, this is one of the recommended way of deploying your switches. Ensure the VTP mode is transparent. So to recap quickly on what we have done, we have configured VLANs for PC1 and PC2 on switch 1, and we've done the same for PC3. We have isolated these two PCs, PC1 and 2, and 4 on the same broadcast domain, VLAN 10. We've created a trunk between switch 1 and switch 2, so we were able to get PC4, 1 and 2 on the same broadcast domain and have reachability between these three. And we have done the same thing for VLAN 20, where PC3 and PC5 were in the same VLAN and effectively the same broadcast domain and had reachability. We've also checked few variation of the configuration affecting the trunk, going from hard coding, trunk on both sides, and then trunk and desirable, and then trunk and access, and validated when the trunk is established and when it's broken. So I hope this lab has been informative, and as usual, if you have any comments or question, please hit me on the section below. Thank you for watching.